Hi, welcome to my talk, Keeping Your Complex Nomad Jobs Sane and Simple with the Nomad Admission Control Proxy. I'm Max Fröhlich. I work as a platform engineer at Serviceware. And why this talk? Why this proxy? Therefore, I wanted to talk a little bit about the evolution of our Nomad job files we observed in the last 4 years. So we started out creating our first Nomad jobs. It looked super simple. We had our one task in there where we said like, okay, here's the container that we want to run that image version 1.0. Great. So then we started to release a new version, right? So it's time to update that version. And we thought like, hey, no, okay, let's not touch the file every time we want to create a new version, but let's use some kind of template mechanism. In our case, we used Terraform, and therefore the Nomad provider, and we could leverage the Terraform's template file to generate Nomad jobs from our templated files. But let's more focus here on the Nomad job file for now. As the next part, we said like, okay, that works super good, but we want to deploy it in different scenarios, so we need to make the job name configurable. And then we said like, okay, we're deploying this now in several ways. We also want to specify the data center. So now we said like, okay, let's add another variable for the data centers, and to align this somewhere with the HCL, we said like, okay, there's an array and you need to do JSON encoding to make it look properly in your HCL file again. And then at some point we said, okay, we have so many running jobs out there. Let's enforce some conventions here. And one of those was like, you should add a owner email address of your team or so. So in case that job goes wild and somebody has to find out who to contact in an emergency situation, there's still like some metadata on that job that may help to put together the pieces. Then also obviously secrets are essential for every application. Vault is perfectly integrated into Nomad. So we wanted to use Nomad and Vault and the policies. So we made the policies also configurable, but sometimes policies are, there are no policies. So we had to make this whole Vault block conditional because it requires at least one policy. Then we wanted to obviously render some, use the template engine, the template block of Nomad to get in some more configuration in there. And in this case, we said like, okay, we have some database that is where the secrets are managed with Vault, for example. So you need to read the secrets from the data from Vault for that database. But obviously, depending on the job name you have, it's maybe a different database. So therefore, we have in our Nomad template block another template variable from another, template mechanism, so to say. And lastly, just for good measures, we throw in some log shipper sidecar to also retrieve the logs of our application. In this case, we did not write down the full log shipper task down here, but we decided let's put that one in a shared Terraform module, which just provides us with that snippet we can then include in all the tasks. So by that time, I think it's good to recall why we bought into HCL. It promised us a structured configuration language that is somehow with a human-friendly component. And looking back at the template we just saw, I would say there's only little humanity left in that template. And we could also like solve this maybe differently. If you look at Nomad Pack, this is another thing we could do, but I saw very similar things in there with that, were very similar to the things we did. We could also maybe leverage more of the HCL2's dynamic configuration blocks, but they don't work well together with certain Terraform aspects. So what I kind of see is that in the future, I'm not sure if that approach will scale for us. So on the one hand on the one side, it's hard to learn for developers for templated jobs. There's no real good IDE support, especially if you start stitching together these job files from different template fragments. It's really hard to track down parsing errors. Like you get like error parsing job at line something, and you have to figure out from which part of your template engine that thing came from. And especially the mental overload, as soon as you have more and more infrastructure you want to connect to, be it like a database, a messaging system, or just setting up some logging, that grows really out of control, I would say. Also, on the other hand, it's hard to control for the operations team to figure out what goes inside your cluster. So we talked about conventions. How can we enforce that? This is like, it's still up to the developers to make sure that it is in like you want to have it to, you want to have to it, like you want to have it in. And also other security concerns, like how do we like narrowing down the policy usage, which team uses which policies, for example, for which job. So at this point, a colleague of mine said, hey, we need an admission controller. And I was like, yeah, sure. What's an admission controller? And if you look up what's an admission controller on the internet, you will land on in the Kubernetes world where that originated from. And they say like, yeah, it's some kind of controller that intercepts the request to the API prior to the persistence, and then the things getting validated and mutated before they go in and are really executed. So is there an admission controller for Nomad, I was wondering? And what I found is I was not the only one looking. There was one person requesting that feature, I think 5 years ago on Nomad, but sadly that issue was abandoned. But that person made some good points and had the idea, like, if it's not built in somewhere, you could still build it as a HTTP proxy in front of the Nomad server. Also, 1 year later, I found out that there is a built-in admission controller for Nomad, but it's not configurable from the outside, so it's only for internal parts of the Nomad server. So, for example, if you use Console Connect inside Nomad, there are certain things mutated on your job before it's getting executed. But this was a good starter, actually. So I could say, hey, I'm taking those existing concepts and building them as an HTTP proxy in front of that. That meant I build a proxy, and this one especially intercepts the job-related calls. For example, Nomad Plan or Nomad Run, if you execute one of those. And then make the processing part in there configurable. So, but where to start? So at this point, it's good to recall that Nomad HateCL jobs are, before they're sent to the server to be executed, that they're first parsed into JSON and then sent to the server. So that was a good starting point where you could say like, okay, the proxy itself retrieves this kind of structure and then can either like forward it to other HTTP endpoints to get potential warnings, error, or mutations back. Or if you don't want to go like full microservice on your proxy, let's build in an open policy agent, and you can bundle the proxy with a set of OPA rules, and which are then taken internally by the proxy to validate and mutate things. When we talk about validation, it means like you get a list of warnings and errors back, and if an error occurs, you just deny the deployment, and when a warning happens, you just attach it to the response and prompt it to the user. For the mutation part, we mainly rely now on JSON patch operations, which are then taken to modify the originally submitted job. So how to look at it more in a code perspective? You either get back a list of errors in your from your processing part, from your validators, or a set of warnings. And for the mutation part, you get this JSON patch, which consists out of a list of operations, be it like add or remove or replace certain parts of your existing JSON document. So here you would see, for example, this operation would initially add a meta field to your document and then goes in there and adds a hello field with the value world into that meta field. So yeah, that is kind of how a JSON patch works. So to summarize it, how the admission controller works is you have a set of HTTP endpoints or OPA rules that are being called when a job is submitted, but they will provide you warnings, error, or JSON patch operations, which are then used to mutate and validate the job. And then if there are no errors, it gets forwarded to the Nomad API. Okay, sounds maybe very abstract, but let's dig into this with some examples. And for my demo scenario, I set up a little cluster, and in there is I want to deploy my app I was talking about in my initial examples. It's a basic Hello World Python app powered by FastRP. In the cluster itself, there's somewhere Vault, and Vault manages a Postgres cluster with databases in there, so credentials are somehow managed by Vault in here. If you want to see logging, we just stick with some cloud provider here, in this case, Grafana Cloud for the log aggregation. And our Nomad API or Nomad server is behind the admission control proxy. So let's go with the first example. We want to enforce certain metadata. See, we as a developer, we just want to deploy and say like, yeah, let's start it. But I have to read all the guidelines and do's and don'ts. And yeah, let's stick with that owner thing here. Somebody wrote in the documentation that it's a must that you add this meta field with the owner email address. But wouldn't it be just nicer if we can deploy it and the server just prompts us and gives us some hints what we might have missed? So for my demo, I set up this my app Nomad job file. You can see it consists out of one group with one task inside, which runs this my app image and exposes a port 8000. Let's have a very short look into that application itself. It consists out of two endpoints. One is which generates a greeting and generates a message and just returns that message to the user. And it also is going to insert that message into the database. And then there's another endpoint /greetings where I'm just fetching all the greetings I persisted yet in the database and just return those to the user. So let's deploy this application right now. I'm going to execute nomad run and saying myapp.nomad. And I'm getting an error. Okay, whoopsie, I forgot to set something. I forgot to set this owner email address. I read this in the docs, but yeah, I just forgot it. I'm new. So, but I can do this easily. So owner equals max@example.org. I think that was the email address. That's my current email address at our company. So yeah, let's execute that one more time. No errors, great. But I think I saw something flashing on the top there with some yellow warnings. Yeah. So what is that about? Yeah, right. We just recently changing our emails and our domain from example.org to example.com. So we're kind of deprecating all the .org email addresses. So let me just update that part here and see if I can run this now. Okay, that looks better. No warning, no error. Great first deployment. That worked really well. So what happened here? We defined these OPA rules in our proxy, where we say like, hey, okay, the list of errors you can produce will contain this whoopsie, you forgot to set the owner. If there is no owner on the meta block, the input part here reflects the Nomad job that is used for the evaluation here. And you can see we can do the same thing with warnings. We can say like, hey, can you please update it from example.com no, can you please update it to example.com? And in this case, there is apparently input meta set, but the email address itself still ends with example.org. So then we add this warning. Okay, let's see how we proceed now. One point I forgot. Learning these OPA language, this rule language can be a bit tricky, but the good thing is it comes with a testing framework built in, so you can define in a test-driven manner all the rules you want to have. So you can say like, okay, test this. If my Nomad job looks like this, then I expect this warning, for example, or like this. And then you have like a set of tests you can execute and make sure everything works as expected. So that helped me at least a lot learning this language actually. So let's head over to the Nomad UI and inspect our freshly deployed job. So here in the Nomad UI, you can see we have our My App job deployed, and yeah, looks good. And let's just open the application and have a look. And it says hello world. Great. So, and if I recall this correctly, I can just say name equals Max, and it greets me. And there was this other endpoint I talked about. That was the greetings endpoint, where I should see all the greetings this message has created yet. So, null. Shouldn't it at least give me like 2 messages now? Okay, what was going on here? Let's have a look. Let's check the logs. Yeah, create a connection to the server, database parts. Yeah. I forgot. I completely forgot to add the database connection parts into my Nomad job, so my application is not able to talk to the database apparently. Okay, let's fix this. So yeah, I need database access. So let's ask ops or the platform team, how do I connect to the database? And they will tell me, yeah, that's super simple. You just need to add the your job related policy, vault policy to your job. Then you can retrieve username and password from Vault. The address for the database cluster itself, you can do this via service discovery. And your database name will be something like your job name. Great. Okay. So if I recall this correctly, I first have to set my Vault policy according to my job name. So it's my app DB access. Then I'm going have to go in there and put like, read the credentials from from Vault for my database. The host and port, I can retrieve this from the Nomad service discovery. And lastly, I have to just set which database I'm going to use. And I have to remember that in this case, my job has a minus in. It's my minus app, and but the database only works with underscores, so it's my underscore app. So will work, but isn't there an easier way? So sure, with the Nomad Admission Control Proxy, we can bake in a rule that maybe just injects, like mutates your job and just injects all the required database access parts you need. So since our application just uses the native Postgres client called libpq, we just say like, hey, Postgres libpq, and let's see if that works for us. So back to our my app Nomad job file. Let's go to the main task and set meta, and let's in this case say Postgres equals libpq. And let's see if we can execute that one. Okay, no errors. That looks promising. It's still deploying. Let's head over to the Nomad UI. So I see here in the Nomad UI there's my application. It just has been redeployed apparently. Okay, let's have a short look at the logs. Okay, great. There are no errors inside my logs. That is already a good thing, right? But let's double check it. I'm going to into my application and bash in here, and I'm going to just check if there is any Postgres related environment variable sets. So I'm just going to say and grab the PG parts which my application requires. Oh, not this one, but this one. So you see PG port, PG password, everything is there, and that looks like it has been generated from from Vault and somehow injected into my application. And also I see the host in there, and yeah, my app is also there with the underscore. Perfect. So let's try out our application. So have one here, and let's open that one again. It says hello world, great. And if I say like name database, it says like hello database. Okay, so greetings, what's in there? It says hello world, hello database. Apparently persisting is happening, my application works, and I just did this with like a very little annotation in my meta block. Great, but how did this actually work? For this, let's have a look at this Postgres rule I baked into my proxy in this case, or I configured into my proxy. In this case, we are not producing any errors or warnings, but we are producing a patch. And a patch consists out of a list of operations, and let's have a short look at those operations. So my very first operation was like, okay, if there is no vault block set on my task, the G and the T here is like a iterating variable, which helps me to find out, go through all the task groups and all the tasks itself. And if I find one task in there that has Postgres set but doesn't have the vault block set, my patch will contain an operation that makes sure there is no the vault block set in my application with an empty policy array. So in the next step, I'm going to look for this still for these tasks and add another operation where I say like, okay, if you require this, I'm going to add this policy. I'm going to append in the policies block a policy, and that's apparently prefixed here with my job name. So it's job name minus db access. Cool. And last, then I'm going to, for the templates block, I'm going to do the same thing. If I find one that requires Postgres, I'm just making sure it has at least a templates block. So if no templates are there, I'm going to add an empty array of templates. And lastly, I'm going to append in this templates block a Postgres env file. I'm going to set the environment variables to true, and I'm going to add this Nomad template block inside my application. So the Nomad template block application looks in this case, if I set it to libpq, it will contain the PG database where I'm going to set the DB name here. I'm going to do the vault secret lookup parts in here, and I'm also doing the Nomad service discovery for my PG port. That's cool. So the cool thing is also, if I'm not saying like, if my application maybe does not use the native PQ client, but let's say I'm using a Spring Boot application, I just can say like, okay, which of those application has not it marked at Postgres equals libpq, but Postgres equals Spring Boot. And then I just can generate a different template. In this case, I'm starting to say Spring Data Size URL and put in the JDBC URL, and I'm going to set like the Spring Boot related values for username and password. And we should be good. So we just saw we were able to inject a complete database configuration part, but just by adding Postgres libpq, or in case we would have a Spring Boot application, for example, we just could just say Postgres equals Spring Boot. Great. This is one thing, but yeah, tracking down errors in your application is usually hard. So you have to figure out like, okay, which application just crashed, find out the logs if they not have been yet already like removed. And so usually what you do is you have somewhere a logging aggregation where all your logs are stored and you can retrieve them later. So yeah, let's set this part up. And yeah, how do I like ship my logs? And the operations team will say, yeah, no problem. You just have to add a Grafana agent as a sidecar. You can retrieve the credentials for the cloud to ship your logs then from a Nomad variable. And you don't forget to also set your task to a leader task in Nomad. So like the sidecar can collect all the logs even if your application crashes. So how would this look in Nomad? Yeah, I have to add this leader in part here in my main task, and then also just attach this whole task in here. So yeah, that's doable, but still with the admission control proxy, why not just like make it way simpler and say, hey, I'm going to ask like logging and maybe equals the logging format my application does, and let this inject my sidecar. And yeah, let's have a look at this. So now in my application, the only thing I am going to do here is I'm going to say logging equals Python minus default, and going to re-execute that thing again. And no errors so far. So let's head over to the Nomad UI. We see here it just has been redeployed, but I suddenly see in my task group there are actually like two tasks running, the main task and the Grafana agent. If I look at the definition of my job, I still see like only the basics I submitted, but if I would look at the full definition in the JSON version, I'm going to find a Grafana agent inside my task block, and you can also see the other task is here marked as a leader. Great. That worked. Does it log? Let's go here and go just open our application one last time and say open up. It says hello world, and I'm going to say name HashiTalk friends. And let's head over to Grafana. Refresh that here. And in the last 15 minutes, we got our HashiTalk friends log. Great, cool, that worked. Nice. I'm going to skip over the rule here I'm added, but it looks very similar to the Postgres part. But I hope I could give you a good idea that it's super simple to validate your jobs and also just like modify them and add like common things you will repeat through several different kind of Nomad jobs you have. There are way more ideas you could add in, like you could realize with such a validation mutation approach with the admission controller. One idea I'm currently working on, for example, is adding the Notary version 2 validation into my deployment process. So I have like DevSecOps parts in my Nomad deployments. Another thing, I think a very common scenario is, for example, if you have like CSI mounts, but you need to make sure your the user ID and group of that mount you just added have the correct ownership, then you have like, you can just inject now a pre-start container that will do this for you. Also, another thing that's easily doable is if you have like an application that cannot authenticate, that doesn't have a authentication layer in front of it, you can just like inject the OAuth proxy sidecar, for example, and like include your application, your unsecured application, in your single sign-on ecosystem. Yeah. So to summarize it, this proxy allows you to shift problems away from the developers board to the platform and operations team. So you don't need to overburden your developers with a lot of boilerplate things they have to repeat throughout every job. And also, you can better secure what goes in and make sure that nobody, like, the freedom you give your developers are still like checked before they actually go inside your cluster. I think you can do cool things with it, but yeah, overusing, I guess the mutation may also feel like weird magic. Obviously, there are still like templates block in there, but you just shifted them to the operations team. Learning this rule language is not it's not simple, I'd say. It took me some time to learn. But try it out. I had a lot of fun building this project. Looking forward to get some feedback, and maybe hopefully at one day the built-in admission controller of Nomad will also just be extensible. So yeah, that would be then this proxy of mine even would not be necessary. Yeah, thank you for watching. Check out the repository and enjoy the rest of the talks.